Thank you for this opportunity to be here and to present and for supporting the development of the toolkits. We really appreciate that. So you might be wondering why petroleum hydrocarbons? So it's been widely accepted and recognized that biodegradation is a significant process that affects the attenuation of petroleum hydrocarbons in the subsurface, and that was the reason for the creation of these toolkits so that we can better understand the conceptual site model for management of the petroleum hydrocarbon sites. So to put this into the context of the BC Contaminated Sites Regulations, we have Technical Guidance 22 that for remediation of groundwater, looking at monitored natural attenuation, where you can look at the trends in the concentration and also geochemical parameters as lines of evidence for attenuation of the contaminants, including biodegradation or the redox parameters. And in addition to that, there is Protocol 13, which also recognizes the role of biodegradation when looking at calculating groundwater concentrations at a receptor location using the screening level risk assessment. Protocol 13 provides for first order degradation rate constant. And also in Protocol 22, when looking at vapor attenuation and vapor attenuation factors, it is recognized that certain class of contaminants, gasoline, diesel-related contaminants, undergo biodegradation, and that if the site conditions are suitable, there is the biodegradation adjustment factor that can be applied for that reason. So we've, as part of that, this toolkit started out as being a toolkit for monitor natural attenuation and enhanced attenuation, and sort of evolved to also look at natural source zone depletion. The first two toolkits, which I'll talk about, will be the looking at the conceptual site model and case studies, and it includes a few BC-specific case studies. And the second toolkit is for methods of evaluating attenuation and source depletion. Toolkits 3 and 4 that Ian Hers will present on is on remedial technology selection as well as sustainability. So just a little bit on toolkits number 1. I think some of you are familiar with the toolkits, and it might be new to the rest of you. In this toolkit, we've looked at case studies, multi-site database studies, and one of the most comprehensive of those review studies was the one based on the California GeoTracker database, where they've looked at data from 4,000 sites with about 10 years of monitoring data, and they've selected locations with greater than 4 years of data and estimated an attenuation factor of 0.18 per year. And when they looked into the data a little bit further and tried to classify the rates based on the technology that was applied at the site, they found that there wasn't a very significant change in that calculated attenuation factor, and that there was a slight increase in the attenuation factors for the more volatile components like benzene using the air phase technologies, whereas pump and treat improved the attenuation rate for MTBE for the more soluble components. And we took this data set and tried to look at, to see if we could, certain sites that had M&A only as a technology applied, and that filtered it down to 72 sites, and the calculated benzene attenuation rate was 0.13, which was slightly lower, but not much lower than the average rate for the 4,000 sites. And to put that into perspective, the timeline of attenuation, starting out with a source concentration of 10 milligrams per liter to the drinking water standard of 5 micrograms per liter, would be 58 years. So toolkit number 2, moving on to that, it's consists of 3 different steps. Step 1, evaluation of M&A and lines of evidence for dissolved plumes. The second toolkit is for use of screening models and measurement methods for natural source zone depletion, including the vadose zone and the saturated zone. And step 3 of this toolkit provides multi-process models for evaluating M&A and plume attenuation. So I'll just focus on step number 2, which in the recent years has shown a lot of changes in a paradigm shift in the way that we think. The attenuation processes can be summarized as biodegradation, dissolution, and volatilization that occur in the saturated zone, but also in the unsaturated zone. So we look at, for example, the dissolve phase concentrations, the gradient horizontally, for trying to look for clues as to changes in the redox parameters that show that there is biodegradation occurring in the saturated zone. But the paradigm shift is sort of looking at it sideways, a vertical gradient, looking at the vapor phase changes in concentration through the vadose zone as that source zone is also undergoing volatilization and degradation. So to be able to quantify those rates of degradation, as some of the recent studies, as recent as a review paper in 2017, that have shown that those vadose zone or the unsaturated zone biodegradation rates can be 1 to 2 orders of magnitude greater than the rates of attenuation or biodegradation that you would get in the saturated zone. And so looking at ways to quantify those rates in the unsaturated zone, it is based on the concept that the reactions that are occurring, they produce gradients in soil gas concentrations, a depleted oxygen with depth, increase in CO2. In some cases, if there is anaerobic degradation, you can have lower nitrogen in soil gas and also the production of methane. And so being able to look at those gradients and have methods of calculating either the flux at the surface or the gradient. So we have the gradient method, which has been in use for a number of years, and we've developed a tool for using that concept to come up with some screening sort of back of the envelope estimates of natural source zone degradation in the unsaturated zone, and also methods of measuring the CO2 efflux at the ground surface for to be able to estimate those rates. And more recently than that, there's been the emergence of using a temperature gradient, because the heat generated from aerobic biodegradation can that change in temperature can be measured, and then from that we can infer the rates of degradation that are occurring in the subsurface. So in toolkit number 2, we do a comparison of these results where we look at some of the pros and cons associated with each of these methods. The gradient method is a simple in concept to understand. It's based on a chemical diffusion gradient. One of the disadvantages is that it's very sensitive to the moisture content. You need to know the effective diffusion coefficient to be able to calculate those fluxes and the gradients. The advantage of using the CO2 efflux method is that it's non-invasive, and there are 2 different methods that I will show later that can be used to measure those. So it's a more direct measurement, but it's also sensitive to natural soil respiration. So there needs to be some consideration to account for that and to be able to estimate the fraction of that. And then there is the temperature method, which is newer, but there have been studies out there where temperature sensors have been deployed at multiple depths and monitored over a long period of time, and that's one of the advantages of this method, that it can provide for long-term monitoring and seasonal changes of those depletion rates. So back in 2016, when the toolkits were first put out, we had a compilation of the rates that have been measured through different methods. Some of them have been classified here as rates measured in cold climate or warm climate, and on average, these rates range from 500 to 1,500 gallons per acre per year, and that's with the exception of some extreme cases. And so toolkit number 1 and 2, I'm not sure if you're familiar with it. It's on the CSAP website, if you've had a chance to look at it. We're finalizing Toolkits 3 and 4, and as part of that, also updating Toolkit number 2. So updating those estimates or compilation of the rates from that would include the thermal gradient method and application of the NSZD assessment to many different sites, because it's been a very evolving topic, very hot topic. There's been a lot of advances in just the last 2 years, new guidance documents that have come out with ITRC document and API talking about NSZD estimates. So there is a lot to cover, and so just to talk a little bit more about the details of the updates for Toolkit number 2. The two different methods are shown on the top left. There's the static trap method and the dynamic closed chamber method, or the DCC method. We were fortunate to be able to do field trials where we could compare the use of these two different methods, look at seasonal changes, and most importantly, looking and coming up with a practical method and creating an SOP for measurement of NSZD estimates using the DCC method, and with using radiocarbon data to correct for the contribution of natural source respiration to the rates that we measure. There is also the development of the VZBL model, which has been updated, and it was released, a new beta version was released last year, and that one includes taking measurement of soil gas, of nitrogen in soil gas, to be able to estimate the methane flux that's generated from anaerobic biodegradation in the subsurface. So a bit of an improvement to that model, which we would like to include as an update to Toolkits 2. There's also been very recent new findings on the influence and toxicity of polar metabolites, and so we would like to be able to update with the new information on that for groundwater remediation. And there is also really exciting changes in new development of new methods for estimating natural source zone depletion based on compositional change of the El Napo through time. So with that, I'll pass it on to Ian. Thank you.
Thank you, Parisa. I'm going to lead us through Toolkits 3 and 4. So there's as you can see, a lot of work that's being done, and Toolkits 3 is a review or a methodology to evaluate remedial technologies. And it's really in 3 different parts. We review existing guidance, both Canadian and US. Some of those guidance documents there are relatively old, but there is the new ITRC guidance that just came out earlier this year. Secondly, we have developed a tool for evaluating remedial options, which I'll go over in a moment. And then third, we really talk about sustainable transitions from active remediation, example recovery, to natural depletion or enhanced bioremediation. And so this idea of a more sustainable approach. One of the things that we found with ITRC is that there is almost no mention of sustainability in their framework. It's an excellent guidance, but I think that's one of the differences in what we're doing. So this is, again, really just a really quick overview. We have a screening process that starts with step 1, identifying the primary mechanism for remediation. And so we feel that that's a very important first step. And I'm just going to skip to the next slide. We'll move back to the rest of the first slide. But really what we're looking at is remedial targets based on 4 different aspects: saturation, which is the LNAPL, the composition, which is the chemistry. There could be containment, which is to prevent migration physically. And then finally, saturation and composition, where we look at both. And in some cases, you may have a need to address saturation. If you have a mobile LNAPL body that's migrating off-site, your objective, as shown on the top line, will be to abate LNAPL migration. One of the important things, though, is the right performance metrics. And this is where the technology and thinking has really changed over the last number of years. And so we don't have time to go over it today, but there's things like LNAPL transmissivity, recovery rates, And then finally, the NSCD rate. And so we recognize that NSCD is a process that occurs at site, often at significant rates, and does affect potentially even the mobility. So there's, just going back to this process again, as part of the Table A screening. Step 2, A is to look at the feasibility. Step 2B is the constructability or implementability of the technology. What we've done is developed easy to follow spreadsheets where 29 different remedial technologies are described, and where there are fill-in areas where you can go and look at your technology and evaluate them with respect to feasibility and constructability. One thing, sorry, I didn't mention is that by looking at the mechanism, you are able to pare down or come up with a short list of technologies. So once you have that short list of technologies, you move to Table B, where you gather information, further information on your technology, and then move on to the sustainability evaluation in Toolkit 4. And again, that's a little bit different than the ITRC approach. So we went over that table. We're moving on, just for sake of time, to Toolkit 4, which we're really excited about. I think it's an important aspect of our framework. So just some definitions. We define green and sustainable remediation as an integration of sustainable development or remediation, looking at the triple bottom line, which I'm sure you all are familiar with, and green remediation, which has been the emphasis in US EPA. And we think it's important to kind of bring these two different focuses together. Overall, we look at the impact of remedial activities on human and ecological receptors in society. There is a new ISO standard which has a nice definition of sustainable remediation. And it talks about the elimination or control of unacceptable risks in a way that's safe and timely and addresses the triple bottom line. And so there's this idea of integrating risk as well in this framework. So we describe the framework and we review the key guidance. We've developed a roadmap where it's a 5-step process. Your CSM, you develop your goals, input from stakeholders, and then the fourth is a really important one. You select indicators, methods, and boundaries. And there is a number of ways to do that. There's best management practices is level 1. Those can also be referred to as sustainable management practices, and so we have for a number of technologies examples of how you can do this, and of course references to guidance. A lot of, there's ASTM guidance and UK guidance on lots of practical ideas that this toolkit will have. Moving on to level 2, you would have sustainable or best management practices and maybe a simple evaluation, a qualitative ranking, perhaps if you're looking at multiple remedial technologies. And then level 3 is a more complex evaluation. You can look at the footprint or multi-criteria assessment. And finally, the 5th step there is to document efforts. If you can't document and monitor and show that you're actually coming up with a sustainable approach, then I think you haven't quite got to where you need to go. So just a little bit on the footprint. We think that there's some useful guidance there. You describe the work, you identify some metrics and boundaries, you come up with an inventory, and you do your calculations. You can look at off-site and on-site impacts, and we've provided a framework for conducting a simplified life cycle analysis for the analysis. And in this little example, the goal is CO2 emissions. The assessment of the footprint really requires 3 key points. The metrics. Our guidance really proposes that it goes beyond environmental. It also looks at social and financial or economic factors or metrics. The boundaries is absolutely critical to define in an appropriate but practical way. So you look at geography, you look at time. For example, if you're evaluating multiple technologies and you evaluate one technology over a very short period of time and one over a much longer period of time, that may be not an equal or fair comparison. And then finally, you look at the technology or technological aspects. Then the third major point is the inventory. So there's a kind of a methodical way of looking at your materials and your chemical waste, your transportation, and so forth to come up with your so-called life cycle analysis. 2 key points. A comprehensive life cycle analysis is not practical. We looked at tools and ways of doing that. It's not possible to look at all the impacts. And so you need to be pragmatic, and hopefully we've come up with an appropriate way of doing that. And then when comparing alternatives, you need to set consistent boundaries. We looked at the tools available, and there are some tools that look at remediation, the Sitewise tool. That's probably the best one and the only one that's really current. There's, for example, a tool called SemiPro, which is for corporations doing life cycle analysis. It's a fantastic tool. It's expensive, has a massive database. It's really not practical to use, but there might be some useful data in it. We found that there was a gap with respect to the flexibility to incorporate BC or other defaults, and it's quite complicated. So we came up with a dashboard. It combines a footprint and MCA multi-criteria tool to optimize and compare a holistic approach, include BC defaults, and there's example worksheets for 7 technologies. It's just the next few slides. I'm just going to quickly show you some things. Obviously, it's a little bit hard to see, but the first worksheet there is just your different metrics there on the left. There's different or indicators and then metrics, measurement units, and then data sources. So we have the green are the environmental indicators, the blue are the social, and the pink there is financial. This is just the completion of the previous table there. Again, the 3 social indicators and then the financial. This is the Footprinter tool. That's a spreadsheet that can be used for footprint analysis. It looks fairly complicated, so we'll simplify it here. Here we have the categories that we've defined, and we look at energy consumption, greenhouse gas emissions, and air emissions. Shown on the upper right there is a drop-down menu, so there are things like, as you can see, there are BC light-duty trucks, vehicles, and those are populated based on BC values. So during the workshop, we'll provide some practical instruction, training on these tools, and we'll cover external available tools for example, the EPA Sitewise tool, but we'll also go over the dashboard and help you kind of look at sustainability and potentially how you might start to incorporate this in your decision making. Here are some of the presentations that are available. There's the spider radar, I guess, plot there. We're just looking at ISCO there, and then on the right-hand side, it shows the greenhouse gas emissions, and for those major categories. This one here is the main greenhouse gas emission is with the production of the persulfate. If you looked at, for example, excavation, it would be if you're disposing of soil, let's say at a landfill in another part of British Columbia, the main greenhouse gas emission would be with trucking and excavators. We don't have electric trucks yet, so it's interesting how when you play with this, you start looking at, oh, can I optimize this technology? And then you realize, well, the main greenhouse gas emission is maybe from something that's kind of difficult to, at least at this point, address. But the point is that we start to think about optimization and sustainability, and there may be some practical things that you can do to make your project more sustainable. So that's the Toolkit 4, and these will be extensively covered on June 19th. We'll have theory, the methods and models, tools. One thing that Toolkit 2, for example, has some really good guidance on just doing an M&A assessment for dissolved plumes. We'll talk a little bit about looking at plume stability and the lines of evidence, ways of going about that. But we'll also talk about the NSCD, and I'm really excited what Parisa is presenting. It's really, I think, kind of leading edge work in the sense that it's really emerging as a pretty hot topic and something that's important. But we'll also present some ways, some practical ways on how to measure this at sites. And we'll, of course, demonstrate some of the Toolkit 3 and show how we can evaluate remedial technologies, and then finally, how we can incorporate sustainability into our overall decision making. So with that, I'm not sure if there's questions, but again, I hope many of you or your colleagues can come to the workshop on the 19th.